This is section 8.6. We're looking at the surface area of a sphere. So we should all know what a sphere is, but we have it defined here. It's a round ball-shaped object. A set of points in space that are given distance radius from a fixed point, the center. Okay, so it's like a circle but in 3D, right? Sphere. So the radius goes in all three dimensions. The sphere is a three-dimensional shape that is often seen in sports. Balls of different sizes are used to play basketball, soccer, and volleyball, to name a few. Consider the balls shown. What shapes appear to make up the surface of each sphere? How could you use the area of these shapes to help you find the surface area of a sphere? Alright, so we're going to skip through here and go straight to the first example because we don't have oranges today. I'm not going to use them. Surface area of an eyeball. So the dimensions of an adult human eyeball are reasonably constant, varying only by a millimeter or two. The average diameter is about 2.5 centimeters. Calculate the surface area of the human eyeball to the nearest tenth of a square centimeter. So the formula for the surface area is given, which is 4 pi r squared. Okay, so another formula to remember. The eyeball has a diameter of 2.5 centimeters, so the radius, remember, is half of the diameter. So you take that 2.5 and we divide it by 2, leaves us with 1.25. We plug in the 1.25 in for r, make sure we square it, and we find our surface area, which is 19.6. And always important, we need to know the units, centimeters squared. Any questions? Very simple. Taking the diameter, dividing by 2, plugging in for radius. Next question asks us for a radius. So it's a little bit more difficult here because the radius is on the right side of the equation. So it's tied to a couple other numbers that we're going to have to move around in order to solve for radius. It says determine the radius of a baseball that has a surface area of 215 centimeters squared. Round your answers to the nearest tenth of a centimeter. So we substitute the values into the formula. So 215 goes in for surface area. We substitute in 4 and pi, which is part of the formula, and we're solving for r. So the important thing here is when we take the square root, we find out that the radius is 4.1 and units is centimeters. Any questions about that? Alright, two very simple examples. Go straight to our key concepts. The formula for the surface area of a sphere of radius is surface area is equal to 4 pi r squared. If you know the surface area of the sphere, you can determine the radius r of the sphere. We do that by reverse operations, which we've shown here. Alright, that is, in a nutshell, 8.6.